Yo, beautiful morning, afternoon, evening, night, whatever time you guys are watching. Uh, it ain't no mystery. That mystery is back here. Still great. What's up, right? Well, I've had this thing in the bag for like a week or two, and I've been planning to post it early, but the problem was I got sick for a week, and I had no choice but to put this in the shelf for a while. Then I thought I have time today, so why not record one and give this to you guys as an assistance that I could give in order for you guys to do good or do well. Who knows if this will help? But anyway, um, this one right here is simply for long division and synthetic. Let's just jump right into it, bro. Peace out. Yeah. Starting off with long division. But here's one thing that I would like to say. It is important that we have to recall some concepts back in elementary or maybe even in grade 7 and 8 in order for us to fully understand how long division works. Namely, if we really want to maximize the concepts that we've learned in mathematics throughout the years, the first thing that we have to remember is the laws of exponents, being product law and quotient law for this discussion. So for example, we have here x times x. We're multiplying two things of the same variable. The concept here is simple. You copy the variable since they're the same thing, and then you add the exponent. Now, this is one thing that I will repeat a lot in this discussion. For the sake of variables like x, there is an invisible one here that serves as its exponent. It's just that in mathematics, we don't usually write them anymore because it is an understood thing. So here, so if it's x raised to 1 times x raised to 1, we add the exponents, 1 plus 1. The answer here is simply x raised to 2. So to follow this one, you have x squared times x. The next example, excuse me, I'm still recovering, I'm so sorry. But this one has a 1 also. So that implies that we will have x raised to 2 plus 1. So the answer will simply be x raised to 3. So that's how it works. Now, we will continue this until you guys get the groove with it. Now, we have x squared is multiplied to x cubed. That will be x. Then again, add the exponents. 2 plus 3. This will be x raised to 5. Now, what if we have numerical coefficients? Guys, numerical coefficients, these are the numbers next to the variables, okay? So the first thing that you have to do here is to simply multiply 3 and 2. The answer there will simply be 6, right? 3 times 2 is 6. Then same concept, multiply the variables. X squared times x squared. This will be x. 2 plus 2, that will give us 4. So as you can notice, earlier we took it a step at a time. Then once we're getting to more examples, we're going with the shortcut of it. Now, how about if you have a monomial multiplied to a binomial? So you have x squared times x plus 3. First, multiply x squared to x. The answer there will simply be x raised to 3. Again, there is an invisible one here as the exponent. 2 plus 1 is 3. Now, the next thing is that we will multiply x squared to 3. Now, please remember this is a short explanation, simple explanation. If you're multiplying a number to a variable, just put them next to each other. So this will be x raised to 3 plus 3x squared. This is your final answer. I just used the color so that you'll know what happened. We call this property as distribution. We distribute x squared to x and 3 by multiplying it. Similarly, you'll have here 4x squared times x minus 2, the quantity x minus 2. So 4x squared times x, that will be 4x raised to 3 because we're simply multiplying the variables. Next, we have 4x squared times negative 2. 4 times negative 2, that will give us negative 8. There's no variable being multiplied here, so it's just x squared. So that's your final answer. As quick as that. So just multiply what you can multiply. The numbers can be multiplied to the numbers, the coefficients, numerical coefficients. The variables can be multiplied to the variables as long as they're the same letter. That's how it works. Now, for product law, as you can notice, we add the exponents when the variables are the same. For quotient law, since it's the opposite of multiplication, we actually subtract. So here we have x raised to 1 again, the invisible one there. So this will be x raised to 2 minus 1. So this will give you x raised to 1, or simply x. We stick with that. We're good with x. Next, we have x raised to 3, invisible 1 here for x, divided. You'll have x raised to 3 minus 1. That would be x raised to 2. Next, x raised to 4 divided by x raised to 2. That's x raised to 4 minus 2. This will give you x squared. Now, once you get the hang of it, notice here you have x divided by x. 1 raised to 1. Now, in complicated explanation here, back in grade 7, we can subtract exponents, right? X raised to 1 minus 1. This will give you x raised to 0. And any term raised to 0 will give you 1. Now, the simpler explanation here is if you notice two variables of the same exponent and you're trying to divide them, just simply cancel it out. And the answer is 1 there. That is a technique that you can do, as a technique that you can apply. Similarly, you have here 3 divided by 3, you can cancel it out because 3 divided by 3 is 1. Remember, if you're dividing something by itself, the answer is always 1. So you're left with x raised to 4 divided by x squared. The answer there is x squared. Next, what is 6 divided by 2? That one you can simplify, that will be 3. X raised to 3 divided by x raised to 2, that will give you x. Now, I wrapped a little bit there, but I hope you understand that these two things will be super important in us doing long division. And speaking of, now let's recall something back in elementary, the importance of the process of dividing. So here, we call the dividend as the number that we are dividing. So for example, 16 divided by 2 is equal to 8. 16 is the one that we are dividing. So that's what we call as the dividend. 2 is the one that we're using to divide 16. That's our divisor. And the quotient is the answer. Now, what do you mean by this part here, remainder plus divisor? This one is best explained by the item below, which is 9 over 2. 9 divided by 2 is equal to 4, and the remainder is 1, and then the divisor is 2. This is how you properly write your answer. Now, I started there, sorry. I can't edit this anymore, please don't hate me. Let's now go to how will this look like and how it will look like for long division. So for example here, you have 52 divided by 4. So 52 is a dividend. It's the one that's going to be inside the symbol, and the divisor will be the one outside, which is 4. So first we start by dividing 5 by 4. So that's what we do, right? Divide 5 by 4. The answer is 1. Then we use 1 as something that we will multiply to 4, and the answer is 4. Now we change the sign, hence the negative symbol here, because 1 times 4 is positive. Change the sign of positive 4, you get negative 4. So do the operation, 5 minus 4, you get 1. Now with this 1 right here, you cannot divide that by 4, so we bring down the 2. So it will now become 12. And then we repeat the entire process. What is 12 divided by 4? You will get 3. 3 times 4, you will get 12. And then we change the sign of positive 12 to negative 12. Hence, 12 minus 12, you get 0. There is no remainder. That's why the answer or the quotient is just 13. So this entire process will be the concept of long division also. That's why earlier we reviewed multiplication by singular variables or monomials, and also monomials by a binomial. So let's go. This is our first example. So the first thing that we have to do here is not going to be complicated. We will simply divide our first term similar to what we did in the long division for grade 3 or grade 4, whatever grade you guys learned that. So you have here x squared as the first term, and here x is the first term from the divisor. So what you will do is you will divide x squared by x, which we reviewed earlier. The answer here is simply x, right? So what you will do is that you will write that on top of 6x. The entire concept here is place value, guys. X and 6x have the same degree, both raised to 1. That's why we align them properly. Next, now have here x going to be multiplied to x. That's the concept. Divide first, so x squared divided by x, you got x, right? Then we multiply. That's the second step. X times x, that will give you x squared. Then x times 2, right here, this will give you what? Positive 2x. Now, You can have different techniques here, but I'll just show you one so that this will be consistent for the entire video. So we will change their sign. Since both of them are positive, I'll make this one negative. I'll make this one negative also. And now I will simplify. So the answer here will be x squared minus x squared, that's 0. So some students do this, like where they cancel it out. You may do that if you want to. Me, it's 0, so no need to write it. Next, what's 6x minus 2x? 6 minus 2 is 4. Now, here's one thing that's important. Do not forget the variable. Let's bring that down. And as you can notice here, we still emphasize the concept of place values. All the ones that are raised to 2 are aligned. All the ones that are just x are also aligned. Next, we repeat the entire process. So we divide 4x by x. So we have 4x divided by x. And again, class, x and x here have the same degree. So we can cancel that out. We're left with positive 4. So this positive 4 should be aligned with 8. Because again, they are of the same degree. They are both constants. Next, we multiply 4 to x and 2. So 4 times x, that will give us 4x. Sorry. I was supposed to bring down 8 earlier. Sorry, I forgot. Look at me now. I'm forgetful. I'm so sorry. Bring down 8 earlier, sorry. How what? 4 times positive 2. That will give you also 8. Now again, we change their signs. They will both be negative. And this one will be equal to 0. 4x minus 4x, 0. 8 minus 8, 0. So the final answer for this question is simply x plus 4. There is no remainder. Okay, so I'll try to give a better explanation on the next one since I made a mistake on this one. Do not forget to bring down like I did, okay? Let's go to the next one. Okay. We have here again, first terms muna tayo guys, x squared, x. Divide those two things, x squared divided by x. The answer is x. Write x on top of negative 7x. Then we multiply. Multiply x and x, you will get x squared. X and negative 3, that will give you negative 3x. And then again, the next step is we change the signs. So x squared will be negative, negative 3x or minus 3x will be positive. So we continue, x squared minus x squared, 0. Negative 7x plus 3x, that will give you negative 4x. And then, yan, I will not forget this time, bring down positive 12. And then repeat the entire process. So we divide negative 4x by x. Let's see what the answer here is. So wait. Ayan. Cancel out the x's. Let's move on from them. We'll get negative 4. Align negative 4 or minus 4 with plus 12. What's negative 4 times x? That will give you negative 4x. Next. What's negative 4 times negative 3? That will give you positive 12. And then again, change their signs. This will be positive. This will be negative. So negative 4x plus 4x, that will give you 0. 12 minus 12, that will give you 0. No remainder again. So the final answer for this example is none other than x minus 4. So as you can notice here, I was a bit fast with explaining this one, but there's one thing that you have to remember. You don't have to overthink the examples. Always remember, we're not dividing a lot of things here. It's just that we do the dividing or the division a lot. What do I mean by that? We start by dividing first terms only. We don't divide x squared by x minus 3, just by x. Okay? Remember that. Let's go with the next one. Here we have x squared minus 5x plus 2 divided by x minus 3. Nothing goofy in here. Let's go with x squared divided by x. That will give you x. Write x on top negative 5x. Do the multiplication. That's the next step. X times x, x squared. X times negative 3. That will give us negative 3x. Change their signs. Minus. This will be plus. Then x squared minus x squared, 0. Negative 5x plus 3x, that will give you negative 2x. Then we bring down positive 2 plus 2. Divide negative 2x by x. This will give you negative 2. Align negative 2 with positive 2. negative 2 times x, that will give you negative 2x. And then negative 2 times negative 3, that will give you a positive number, positive 6. Then we change their signs, positive, negative. We simplify. Negative 2x plus 2x, 0. 2 minus 6, that will give you negative 4. So this is the important part of our discussion. Now there is a remainder. If you remember earlier, we discussed the concept of how to write them properly. Well, it applies also for long division. So our quotient here is x minus 2, and then our remainder is negative 4. So we'll have plus negative 4 all over the divisor being x minus 3. So this is the answer. Now this one right here, to simplify it, we can write this properly by having x minus 2 minus 4 over x minus 3. So what happened in this second one is we distributed the negative sign to the positive one. So this is the simplified version of it, the final answer. Let's go with the others. Let's go. I don't want to get bashed for having an hour video. So let's go. Next, same step, x squared divided by x. X ulit yan, guys. X. Multiply x to x, you get x squared. Multiply x to negative 4, you get negative 4x. I told you guys, this is repetitive. That's why you have to get used to the review. Now we change their signs. You will have x squared minus x squared, 0. Negative 6x plus 4x, you get negative 2x. Now we bring down 1. We will have negative 2x plus 1. Divide negative 2x by x, you get negative 2. Align negative 2 properly. Multiply negative 2 to the binomial, you will get negative 2x. Then negative 2 times negative 4, you will get positive 8. Change their signs. This will give you negative 7. So the final answer here is x minus 2, and what would that be? Plus negative 7 all over x minus 4. Or again, in simplified version, this should be x minus 2 minus 7 over x minus 4. Okay? I hope I did this correctly though. Did I? Yeah. Yeah, I still got it. Yeah, we good. Let's go to the next one. Now we have a longer example, but it's fine. It's still complete. Nothing goofy yet. So let's continue. You have your first terms. 3x cubed divided by 3x. Divide that. You get x raised to 2. Align that here. Again, same concept. Multiply. What's x squared times 3x? You get 3x cubed. Next, what is x squared times 2? You get 2x squared. Change their signs. You will get 9x squared. Excuse me, we bring down negative 6x. Divide again. You have 9x squared divided by 3x. Repetitive process, you get 3x. Align that with negative 6x. Then we multiply yet again. 3x times 3x, you get 9x squared. 3x times 2, you get 6x. Be careful with this, guys. You have to remember, change their signs, both of them. Now you have 9x squared minus 9x squared, 0. Negative 6x minus 6x, that's not 0. That's going to be negative 12x. Remember that. Bring down negative 8. Negative 12x divided by 3x. You will get what? You will get negative 4. So minus 4. So negative 4 times 3x. This will give you negative 12x. Negative 4 times positive 2. This will give you negative 8. And when you simplify this whole thing, you don't just go with it without changing their signs. So this will be both positive, and the answer is actually 0. No remainder. The answer here is simply x squared plus 3x minus 4. So that will be it for this example. Okay, I think we still have some more. Let's go. Okay, okay. You have your 6x squared plus x minus 9 divided by 2x plus 3. Same process. 6x squared divided by 2x. This will give you 3x. 3x here. 3x times 2x. That will give you 6x squared. Then next we have 3x times 3. You get 9x. Change their signs. Now, here's one thing that I've noticed with my kids. Guys, if it's just x, there's also an invisible 1 next to it as a numerical coefficient, okay? So it's basically 1x minus 9x. And the answer here will be negative 8x. Then we bring down negative 9. Bring that one down. So let's have 2x, negative 8x divided by 2x. You get a negative 4. So 3x minus 4. Negative 4 times 2x. You get a negative 8x. Negative 4 times 3. You get ourselves a negative 12. We change their signs, both positive. Negative 9 plus 12, we get there a positive 3. So our final answer is 3x minus 4 plus 3 over 2x plus 3. Are we correct here? 3. I just have to double check because I'm a bit past right now. I might forgot some things. Okay, I think we're good. We're good, right? Yeah. So this is the answer. Let's go to the next one. Okay, this is one of the goofy examples that you're gonna see here, and this is where I will slow down a little. I want you to observe this example right here. X raised to 3 plus 8. This example is actually incomplete, and it's important that when we're dividing things, it's complete. It's like the best explanation that I can give here is like when you're dividing 1000 by something, you know, like for example, in grade 3 you divide 1000 by, let's say, 1. I just want to show the process, right? So the first step is you divide 1 by 1, you get 1. 1 times 1, you get 1, you change the sign, 1 minus 1, you get 0. But 1 is not the answer here, guys, right? You have to do something. Repeat the process. What is 0 divided by 1? 0. 0 times 1, 0. Change the sign, 0, bring it down, 0 divided by 1, 0. So it's something like this. And then if you continue this process, you're going to get 1000 as your final answer, right? Now, what is the emphasis or what's the importance of this in line with x raised to 3 plus 8? X raised to 3 plus 8 is incomplete in the sense that it starts with the third degree and then followed by a constant. So the concept here is that we're gonna fill x raised to 3 plus 8 in the middle. What is missing here? So we don't have an x squared, we don't also have an x, but we have an 8. Now here's a concern. Is this the right interpretation? No. There should be something next to those x squareds. This is 0, this is 0 also, because they're simply there to fill up a place value for this example. So that's how we will start here. X raised to 3 plus 0x squared plus 0x plus 8. So again, the important thing or in here in example 7 is that you have to take note that we have to put in some zeros in between in order for us to actually answer this completely. These zeros are here for place value purposes. So if you continue the process, you'll have x raised to 3 divided by x. You will get x squared. So you can notice the answer is x squared. We can align it with the 0x squared for place value purposes again, because this is going to play an important part with this one right here. So x squared times x, you get x raised to 3. X squared times 2, you get 2x squared. Now, if we did not do what we did earlier, which is put in these zeros out here, we don't have anything to subtract 2x squared with. That's why we have to put the 0x squared. Now, we have 0x squared minus 2x squared. That's negative 2x squared or minus 2x squared. We bring down 0x again. This is important. Now we have negative 2x squared divided by x. This will give us negative 2x. So we write here minus 2x. We do the same thing over and over. Distribute. We get negative 2x squared then negative 2x times 2, that will give us negative 4x. Now we change their signs, both will be positive. This will be 0 plus 4, 4x. Then we bring down the 8, and we'll have 4x plus 8. Repeat the process, 4x divided by x, you get 4. Positive 4 here, 4 will be distributed to x plus 2. So 4 times x, you get 4x. Then you have 4 times 2, that will give you 8. Now we change their signs, and the answer will be 0. So your final answer here is none other than x squared minus 2x plus 4. That's how you answer something in long division. The zeros here for place value is going to be important also for synthetic division. That's why I have to emphasize a lot of possible ways to explain it. Okay, now let's have example number 8. Have here x cubed minus 125 over x minus 5. Similar situation. Something is missing in between. Now I have a mistake here. This should be 5x minus 5. Why did I write that? Okay, I'm so sorry guys. This is x minus 5. Okay, anyway, you have 0x squared plus 0x minus 125. A lot of you might be wondering, sir, why are they still positive? Because again, we're adding them for place value. Even if there is a minus symbol there, you don't have to worry about that. It's always plus 0x squared or plus 0x or plus 0x cubed depending on the given. Okay, now let's go. X cubed divided by x, you get x squared. X squared on top. Distribute this one, you'll get x raised to 3. X squared times negative 5, you get negative 5x squared. Change their signs, minus, plus. You get yourself a 5x squared. We bring this one down. You get a 0x here. Repeat the process. 5x squared divided by x. You get yourself a 5x plus 5x. What we do here again is we distribute 5x times x, 5x squared. The next, what's 5x times negative 5? You get yourself a negative 25x. We change their signs, and we will be given with 25x minus 125. Repeat the process, 25x divided by x. You get yourself a 25. This 25 will be written here. Then again, 25 times x, you get yourself a 25x. Then 25 times negative 5, you get yourself a negative 125. Change their signs, minus, plus, the answer is 0. Therefore, the remainder is x squared plus 5x plus 25. That's about that. And I think we have one last example to wrap about. My goodness, almost 30 minutes for this one, but I hope that you guys are getting the concept. Now here, this is a complicated example because it's a bit long, but that's the only complicated part. All you have to do is to repeat that process. But there's one thing here that's a bit fishy. Observe that you have x cubed here and x raised to 4 here. So the important detail here is we have to rearrange. So how do we rearrange a given polynomial, my dear children of St. Augustine, or my children in particular? All we have to do here is simply arrange them from highest degree or highest exponent to lowest, which is the constant. Okay, so in this case, we will have x raised to 4 first, followed by the 5x cubed, followed by the 9x squared, followed by the 11x, and the minus 10. Guys, please do not forget to, again, remember their signs. Then you have here x squared plus 3x plus 2. Sir, is there anything that we have to do differently because it's now a trinomial? No. Same concept. First terms, x raised to 4 and x squared. Divide those two things. You will get x squared in here. So you put that here. Now you distribute x squared now to a trinomial 3 times. You will get x raised to 4, 3x cubed, and 2x squared. It's fine, guys. Then we change their signs. So we will have 2x cubed plus 7x squared. Then we bring this bad boy down. We have plus 11x. Same process, 2x cubed divided by x squared. You get yourself a 2x. So plus 2x. 2x again will be distributed to three things in particular. So 2x times x squared, you get there a 2x cubed. 2x times 3x, you get yourself a 6x squared. And 2x times 2, you get yourself a 4x. Now we change their signs. So you will have 7 minus 6, that's equal to 1. So x squared, then 11 minus 4, you get yourself a 7x. Then we bring this negative 10 down. So minus 10. Then you have x squared divided by x squared. The answer is 1. So plus 1. So 1 times everything, you'll have x squared plus 3x. Sorry, x squared plus 3x plus 2. Change their signs, they will all be negative. And the remainder here will be 4x plus 8. We can no longer continue here. So therefore, the final answer, I'll just write it here in the middle. This should be x squared plus 2x plus 1 plus 4x plus 8 all over x squared plus 3x plus 2. It might have been long, but it's the same thing, same process, nothing to really worry about. So that's how long division works. Man, that took us 30 minutes, but I think at least that we're good. Now, what we're going to do is introduce syntactic division and how it works. Now, I think syntactic division might be easier, but it's important again that you understand how long division works, because without long division, we will not be able to do syntactic quickly. Okay, let's just jump right into syntactic, should we? Okay, if you haven't noticed, this is a Life of Pablo reference, hence the opening. But anyway, if earlier we recalled how to divide and multiply variables or monomials or binomials or either, now what we're going to do is to identify numerical coefficients as a review. Now this will be important for syntactic division. First, if you have here an x squared, again remember there's an invisible 1 next to that. So the numerical coefficients for this given is simply 1, 10, and then negative 24. 1 is the numerical coefficient of x squared, 10 is the numerical coefficient of x, and negative 24 is the constant term here, the constant. Now, the thing that I want you to understand is that we don't include the variables here. We just look at the numbers, but we include their signs properly. So you have here 3, 4 positive, and then negative 5. So this is 3, 4, negative 5. I'm sorry, negative 5. Okay? Similarly here, there's an invisible 1. So 1, 6, 8. Here, there's an invisible 1, 1, negative 7, 10. Here we have 10, 27, negative 6, and 9. So that was a bit fast, right? But it's not complicated. All you have to do is to look at the given, identify the numbers, the numerical coefficients. Again, they are the numbers next to the variable. Do not forget their signs. Now, for syntactic division, basically, it was introduced in algebra in order for us to solve polynomials by division quicker or quickly. So this one right here will be important. What's the meaning of x minus c or whatever that may be? So in syntactic division, there are a couple of things to remember. First thing is that we make sure that it is in standard form. Meaning of standard form is that, again, this was similar to what I discussed earlier, where the given must be arranged from highest to lowest degree of exponent. Next is we identify the numerical coefficients, which was done earlier or in the previous slide. Now the divisor must be in the form of x minus c, or x plus c, or even 2x plus c, or 3x plus c. It's going to be different kinds of concept. Now what are we trying to say here? So that we will be able to identify the constant number that will be used in syntactic division. Now what I will show you here, or for the two simple cases, not including the difficult or complicated one later, is that we have to apply the properties of equality. So let's say we have x minus 3. In order to identify the constant term here, or the constant number, we equate this to 0. After that, we do what we do. We either add 3 to both sides or we transpose. Hence, you will have x is equal to 3. Here you have x plus 3, and again, you may do the properties of equality here, or you may do the technique, which is transposition. Positive transposed to the other side, you will have it as negative. So this is how it will work. This simple exercise here will be important for us to do synthetic division properly. So let's say that we have the given x squared minus 7x plus 10 divided by x minus 5. So your choice if you want to write it this way in order for you to get how it works. So you have here your x minus 5, and then again, if you equate this to 0 and then transpose your negative 5 to the other side, you're gonna get x is equal to 5. Now the entire purpose of this is this will be your constant here in this location. Now you have here 1, negative 7, and 10 as your numerical coefficients. Okay? They are for the dividend. So the 5 is from the divisor, the 1, negative 7, and 10 is from the dividend. Now let's have this synthetic division example. So as you can see here, 1, negative 7, and 10 are listed, and the bar is important. Please leave space for the answers here and at the same time with the products. So what you will do here is simple. You will have a bring down, multiply, simplify, and repeat process in order to get the answer. Okay, so we will use an example that will be similar to this one. So let's have here, for example, x squared plus 10x minus 24. Again, it's your choice if you want to draw the long division format. If you want to do it like this, okay lang, it's fine. So x squared plus 10x minus 24. Now again, x minus 2, your divisor, should be equal to 0. We transpose the negative 2. Since we transpose it, the sign will change. X is equal to positive 2. So now, when we draw this, we have our constant 2 here. Then now we identify their numerical coefficients. For x squared, again, there's an invisible 1 next to it, so 1. For 10x, it's 10. For the constant, it's negative 24. Now, one of the things that is important here is you draw a bar here. Again, I put some space in there. Some students tend to put the bar underneath 110 and negative 24. That's incorrect. Put the bar while also leaving some space for the products. Because what we will do here is simple. We bring down the 1. Then we multiply 1 to 2. So 1 times 2, the answer will be written here. Okay, 1 times 2 is 2. Now, I put the word simplify because you're going to do whatever operation is asked of you. So since they're both positive, we add them. 10 plus 2, the answer is 12. Next, we repeat the entire process. So 12 times 2, that will give you 24. So we write 24 here. So what is negative 24 plus 24? That is 0. Now, the concept is that we always start with the constant at the... Ayan na, nagkamali na si sir. We start with the remainder at the end. So it's 0, so no remainder. Followed by the constant term. Then followed by the x term. So the 1 there serves as the numerical coefficient. Hence, the answer here should be x plus 12. So again, the x term and the constant term. It's positive 12, so plus 12. The constant term, right? So 1 is for x, meaning that's a numerical coefficient, so just x. That's how synthetic division works. Let's try another one. This one is a bit longer. So again, you can simplify it na kung ayaw yung ginawa natin kanina if you don't like what we did earlier. Identify the numerical coefficients here. 1, 8, 10, 21. Okay? So x plus 7 equal to 0. Transpose 7. X is equal to negative 7. Okay? Now we're complete with the details. Negative 7. We have 1. We have 8. We have 10. We have 21. Draw a bar again. Now we do the same thing. We bring down 1. We get 1 here. This is important. Be careful with this, my dear children. What's 1 times negative 7? Okay? You will get a negative 7. So by simplifying, what is 8 minus 7? You get a positive 1. So you do the same thing. 1 times negative 7. Write it here. This will give you negative 7 again. 10 minus 7, that will give you a 3. Then this 3 again will be multiplied to negative 7. The answer will be written below 21. The answer is negative 21. This will give you a 0. Always remember, constant. Oh God, why am I wrong again? Remainder, I mean. There's something constantly bothering me, I guess. Joke lang. Joke lang. Humuhugot tayo, no? No. This is the x. So what's after x then? Well, x squared. That's it. I would like to reiterate, sorry, remainder is always last, followed by constant, followed by x squared, x cubed, x raised to 4, depending on the given. So the answer here is simply x squared plus x plus 3, no remainder, so we good in here. Let's have some more. Now this one's a bit long. Again, you have x plus 3 is equal to 0, transpose 3, you get x equal to negative 3. Here you have 10, 27, negative 6, positive 9. Then we do this thing again. We have negative 3, we have 10, 27, negative 6, positive 9. Draw a bar, bring this thing down, you'll get a 10. Multiply 10 to negative 3. And then the answer must be written on the next one. The answer here is negative 30. 27 minus 30, that's negative 3. Negative 3 multiplied to negative 3, that's positive 9. Write it here. So negative 6 plus 9, that will give you a 3. So 3 times negative 3, you get a negative 9. Write it here. So I have a negative 9 here. 9 minus 9, 0. So in this case, again, okay, let's make sure I'm correct. Remainder, constant, x squared. Okay, again, this one right here serves as their numerical coefficients. So this will be 10x squared minus 3x plus 3. No remainder, so this is your final answer. Yay! Okay. Let's have some more. Okay, nothing goofy here. Continue lang tayo. X plus 6 equal to 0. Transpose. X is equal to negative 6. Wala na akong boses. 1, 15, 47, negative 38. Have negative 6. 1, 15, 47, negative 38. We put a bar below. We bring down 1. Multiply 1 to negative 6 and then write it here. You get a negative 6. 15 minus 6, you get a 9. 9 times negative 6 is negative 54. Write it here. The answer here will be negative 7. Negative 7 times negative 6. Negative 7 times negative 6 is 42. Negative 38 and 42, that will give you a 4. So there is a remainder. There is a constant. There is an x and an x squared. Okay, so the answer here will be x squared plus 9x minus 7 plus 4 over x plus 6. Again, this is the same concept for all division. You have the remainder over the divisor. Okay. Let's have this one right here. This one is going to be a bit goofy. It has some steps that it has to do first. Now, here you have 2x plus 3, right? You equate that to 0, right? Then what do? You transpose 3, right? The answer there will be 2x is equal to negative 3, right? But now we have to divide both sides by 2. This is an application of the division property of equality. You will get x is equal to negative 3 over 2. Now, my suggestion is that you don't simplify to decimals. Much better if they're in fraction. They're not going to be goofy. It's fine. So now here we have 6, we have 1, we have negative 9. Yeah. Should it be positive? It's fine. So we have here negative 3 over 2. Multiply it to 6, 1, negative 9. Same concept, bring down the 6. So we have 6. Multiply that to negative 3 over 2. You're gonna get a negative 9. Am I correct to say that? Yep. So 1 minus 9, that will give you a negative 8. The negative 8 times negative 3 over 2, that's gonna give you a positive 12, right? Positive 12, right? Yeah, positive 12. So, negative 9 plus 12, you're gonna get a 3. Now, sir, is this the answer? Should we continue? Unfortunately, no. But here's the thing. Unfortunately, it's not yet done. We have to divide these two things by 2. You think, sir, why are we dividing the two things by 2, but the last one, no? The last one here is the remainder, so we don't touch it anymore. We leave it as it is. The 3, we leave it as it is. We divide 6 and negative 8 by 2 because of the 2x that we have right here. The 2x here has a numerical coefficient, unlike the other examples. They're x minus 3s, x plus 3s, or whatever they may be. Here, there is a 2x. So we divide this entire thing by 2. Again, except the remainder. And what we will have here is 3 and negative 8. So the interpretation or the answer to this example will now become 3x. Ayan, ang galing ko talaga mag-math, guys. Negative 8 divided by 2, ang sagot ay negative 4. Please forgive me. 3x minus 4 plus the remainder, 3 over 2x plus 3. Okay, that's it. I'm so sorry if there are some mistakes with my wordings and I have to correct them. You know, your boy is tired. It's 47 minutes, bruh. We have some more. Let's go. Okay. Now it's like earlier, there are some missing parts here that it's important. X plus 2, no numerical coefficient, nothing to worry about. X plus 2 is equal to 0. X is equal to negative 2 by transposition. This one will have 1 and 8. Partially correct. What's missing? What's missing here, my dear children? X cubed plus 8 can also be written as 0x squared plus 0x plus 8, right? So that's how it works too. We're gonna have here 1, 0, 0, 8. Then you have your negative 2 here. Then we continue. So you have 1 brought down, 1 times negative 2. Then you write the answer here. You have negative 2. 0 minus 2, negative 2. Negative 2 times negative 2, you get a positive 4. You get a 4 here. 0 plus 4, 4. 4 times negative 2. Then you write it here, you get a negative 8. 0 minus 8, 0. This is your remainder. Okay, I did not forget this time. This is your constant. This is your x. And this is your x squared. And therefore, our final answer should definitely be x squared minus 2x plus 4. And actually, that was our answer earlier. We used the same example, but again, the important part here is the zeros. Okay, that's very, very important. Do you have some more? Do we have some more? I don't think we have something more. And that is actually it, my dear children. Okay, 50 minutes. I'm good with that. Yo, that ends our video for long division in synthetic. I've given a lot of examples, a lot of practices here, and you may check out your book. You may check out the things that we've done in class to help you out here. And again, this takes practice, repetition, so that you'll be able to get the hang of it. That's how these things work when it's a skill-based kind of lesson. And it's difficult to answer the questions, how are we going to use this in real life? Actually, we're using the skills in division of polynomials in order for us to work on our next lesson, which is remainder theorem, factor theorem, and rational root theorem. So it's a connection of lessons pa. That's why it's important that we establish this one properly. Anyway, that's all from me. The goatee may not be here, but the goat wants to say, in case you don't see me, good morning, good afternoon, good evening, and good night. I have to go watch a film today. Bye-bye. Whoa.